and angle CAD is 2 and 4. That is just some good old angle addition. Now I know that I want to prove that BAD and CAD are equal to each other. I know that those pieces are interchangeable. I know that their measurements add up to make them equal, but I need to show it mathematically. How I'm going to do that is by taking one of the equations, it doesn't matter which one, and taking out their interchangeable pieces. So let's say I take the first equation, equation. And instead of angle 1, I know that angle 1 and angle 2 are interchangeable, so I'm going to write angle 2 instead. Instead of angle 3, I'm going to write down angle 4. So taking out one small piece and replacing it with another, even if it was multiple, is called substitution. And then now I realize 2 plus 4, well, that equals BAD and CAD, so they must be equal to each other, your transitive property of equality. Okay, I've just proven that those whole angles are equal to each other, so I might go in here and mark that they're equal to each other. And now I know that I can prove that those two triangles are congruent because of side angle side. It's okay if you have different orders of the letters than what it's in your proof statement. That's fine. As long as you're talking about triangles and not angles, because angles, the order does matter. Side, angle, side. Okay, I'm going to be honest. I totally forgot what I'm supposed to prove next. I don't remember. And that is very common, that once you're done proving that two triangles are equal, you're like, wait a minute, what was I supposed to prove again? And that's okay. You've gotten really, really focused on like proving that these triangles are equal. So always take a step back and reevaluate. Okay, I just proved that those two big triangles are equal. I now have the world of CPCTC open available to me. I now need to see, okay, well, what am I going to do in order to prove the next piece? Now I need to prove that angle 5 and angle 6 are equal to each other. Realize that angle 5 and angle 6 are not a part of triangle BAD or CAD, right? It's like this weird part angle that's in the middle of it. But angle 5 and angle 6 are a part of these two triangles. So I need to prove that those two triangles are equal in order to then say that angle 5 and angle 6 are equal. Which means I need to then use CPCTC to prove that that AXD and AYD are equal. Between AX, here I shouldn't have, oh no. Okay, I shouldn't have erased these guys. Between those two triangles, I already have 3 and 4 as equal. So I've got an angle, and then I have AD equals AD. So that's a side. And now I probably want to have another angle in order to make it work. I would love to be able to prove that this angle and this angle are equal, which just so happens to be corresponding parts of triangle BAD and CAD. Right? So angle 7 and 8 are also a part of triangle BAD and CAD. So I can say that those guys are equal right now because I just finished proving that those triangles are equal. So since those triangles are equal, then I know that all of their corresponding parts must also be equal. Angle 7 equals angle 8 because of corresponding parts of congruent triangles are congruent. Please, please, please remember that CPCTC always comes after triangles are congruent. You cannot use it to prove that triangles are congruent, and you cannot use it before triangles are congruent. It always has to come after. Now that I've proven that those two angles are equal, I can go in and say 4 arc marks. Wow. Now I can say that AXD and AYD are equal because of angle, side, angle. AXD. Is congruent to triangle AYD. So this is a situation where I'm just where I like connected the bottom part of my proof, the fact that I needed to prove that 5 and 6 were equal. I knew that, well, that angle 5 and 6 are part of these other triangles. So I would need to prove that those two triangles are equal. But my given was leading me to prove that two different triangles were equal. So trying to find the common ground between, I need to prove these AXD and AYD are equal, and then I also needed to prove, or I was being led to prove, that triangle BAD and CAD were equal. So trying to find the point of connection between the two is kind of how our thought process is working. We're working from top down and bottom up at the same time and trying to figure out where they all piece together. 8, angle, side, angle. Okay, now that I've proven that they are equal, now I can say that angles 5 and 6 are equal because of CPCTC. Oops. Corresponding parts of congruent triangles are equal. QED. All right. Here we don't have a guiding step process of being like, hey, you're first going to have to prove that these triangles are equal before you can prove that these other things are going to happen. Now we have to try and figure out what that middle piece is ourselves. So we're given that AB is equal to AC, and we're given that RB is equal to RC. Right away, I'm noticing that I could prove that triangle BAR and CAR are equal because I could do side, side, side there. So that might be helpful to then get CPCTC going on. I want to prove that SB and SC are equal, which means I'm probably going to want to prove that ABS and ACS are equal to each other. And I'm going to have to do that by knowing some angle pieces. Okay, so I've got an idea of like, okay, I know I can prove bar and car, the triangles BAR and CAR are equal to each other. So I'm going to just go ahead and do that. And then once I cross that bridge, then I'll like take a step back and look at how is that going to help me with the two bigger triangles? Because now I've got too many thoughts going on in my brain, and I've got to handle some of them. And I had remembered that I was going to prove that triangle BAR and CAR are equal because of side, side, side. So I'm going to need to say that AR equals AR. I am going through this really fast because this is accelerated. If you are struggling with knowing when to, like how to prove it, like spotting side angle side or side 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 or angle side angle or all of those, don't be afraid to write out all 5 reasons for every single question. Write out side side side, side angle side, angle angle side, angle side angle, and HL on your paper at all times, and then look at what you have. We were given 2 side lengths. That probably automatically eliminates quite a few of our reasons, right? It would either be side, side, side or side angle side in order to prove it. And then you look at it and say, well, do I know anything about those angles between the 2 sides? No, not really. Can I say anything about the other side? Yes, I can. And so that's kind of the thought process that should be going along there. Think about what you're given and then which of those steps is it going to be. That's our reflexive property. Now I can say that those two triangles are equal because of side, side, side. All right, now I've proven that those triangles are equal. Now I can say that all of their corresponding angles are also equal. So try and think about this in an intelligent way. Work smarter, not harder. I want to prove that SB and SC are equal, which I could either prove that the smaller triangles at the far right are equal to each other to use CPCTC to then prove that those pieces are equal, or I could do the big triangles that are half of the whole diagram, right? ABS and ACS. And I noticed that what I've proven so far with the triangle already, the triangles that I've proven to be equal already, I've already gotten pieces that are helpful then for the big triangles. So I'm going to focus on the big triangles because I think that's going to be easier. You could focus on RBS and RCS and still prove it. I just think it would be harder. So I'm going to prove right now I've got AB and AC are equal between those two big triangles. I could even draw them separately if I so desired. Again, it doesn't need to be perfect, but A, B, S, A, S, C. I have already that this guy is equal to this guy. I could prove that AS equals AS. I could even, if I was feeling super, super lazy, go in here and add it into step 2. So I don't have to write that reason again, because one does not rely upon the other. AS equals AS is true. You could say it at any point in the reasoning because you haven't done anything to need it to be true in the proof. It's true because of the diagram. Okay, so I've got 2 side lengths that are going on right now. Thinking again about the 5 ways I can prove. They're not right triangles, so no HL. I have 2 side lengths, which means I'm going to be SS or SSS or SAS. And so I'm going to think about how can I make the connections between the triangles I've already proven and the triangles that I want to prove. And I realize that angle A is a part of both triangles that I'm talking about here. I'll call it angle 1 and angle 2. With BAR and CAR, now I can say that angles 1 and 2 are equal, which, hey, angles 1 and 2 are also in our bigger triangles. And once I can prove that those 2 guys are equal, then I have side angle side. So now I get to say that angles 1 and 2 are equal. Notice this pattern here, that after proving 2 triangles are equal, almost always, just always, you're going to be using CPCTC immediately afterwards. If it's not your final piece to say that these 2 triangles are equal, then you're going to prove 2 triangles are equal, and then the next piece you're going to say CPCTC because you want to use that piece to do something else with it. Now I've said that those 2 guys are equal. I can then say that the 2 triangles are equal, ABS, ACS. Because of side, angle, side. And now that I've proven that those 2 triangles are equal, remember, taking a step back, I want to prove that SB and SC are equal to each other, which now I can because of CPCTC. What was it again? A SB, SC.